Hello, this is Elizabeth Pluswick, and this short video is about the difference between effective interest rates and nominal or contract interest rates. So let's look at an example first, and then we'll get to the formula to convert between the two types of interest rate calculations. This is example 15.3 from the handout, from the problems in the handout at the back of the handout. So in this example, the interest rate, a bank charges interest rate at 1% per month, or alternatively, the bank charges 12% interest per year. What's the difference? 1% per month versus 12% per year. We think it might be the same, but no, because 1% per month for the whole year is compounded interest, right? The investment or the balance due, whichever it may be, the bulk, the sum of the money earns interest on interest every month. Interest is compounded every month. So that interest adds back onto the principal, and then that bigger principal continues to earn interest for the next month, and so on. So let's look at the difference that this makes. At 1% per month, our future value of the account is the present value, $1,000 today, times the quantity 1 plus the interest rate per month, times the number of interest compound, or excuse me, taken to the exponent of the number of compounding periods in the year. So here we have the final balance would be $1,126.83 if that interest is compounded every single month. Alternatively, with no compounding, just flat interest figured out once at the end of the year at the rate of 12%, we take the same formula, future value equals $1,000 present value times times the quantity 1 plus the annual interest rate and only one compounding period, because that 12% is for the whole year. That would give us just $1,200 even. So the difference in interest, just due to compounding more frequently, monthly, rather than just once per year, the difference is $6.83. Now let's look at the formula to calculate in between, to flip-flop between these two, effective and nominal interest rates. I subscript E is effective annual interest rate equals 1 plus R divided by M to the mth exponent, and then minus 1 to get it back into just a percentage interest rate. So what does that mean? The annual effective interest rate for the whole year, annual effective interest rate, not contract or stated, but effective interest rate with compounding, is 1 plus the nominal or stated contract interest rate for the whole year, divided by the number of compounding periods in that year. Then take that whole thing to the exponent of the number of compounding periods per year, same number, and then subtract 1. So let's look at an example of that. From page 610 in the handout, we have this example 15.12 in your handout. A bank charges 1.5% interest per month on a credit card balance. So two questions. What is the nominal or contract rate for the entire year? And then what is the actual effective interest rate for the whole year? So to figure out the nominal interest rate first, or the contract rate, is simply the monthly rate, 1.5% per month, times 12 months. So in name or contract rate would be 18%. Simply multiply the monthly percentage rate times the number of months in the year. 18% nominal or contract interest rate. The effective interest rate, however, is going to be a higher amount because effective interest rates take into effect the compounding of interest every single interest period. So effective rate using our formula is 1 plus the monthly interest rate to the exponent of 12 months in the year, 12 compounding periods in the year, and then minus 1. On your calculator you get 0.1956, which equates to 19.56% effective interest rate. So the bank will tell you that they're charging only 18% interest rate per year, and actually you're paying 19.56% interest rate. If this was a credit card, balance, you're paying more. You actually pay the effective interest rate because of compounding interest every single month. Then you're paying interest on the interest. So it actually turns out to be a higher effective rate.